So number 5. Number 6 is asking biphenyl C12H10 is a non-volatile, non-ionizing solute that is soluble in benzene at 25, I want to say that's degrees Celsius. The vapor pressure of pure benzene is 100.84 torr. What is the vapor pressure of a solution from dissolving 15.4 grams of biphenyl in 29.7 grams of benzene? Okay, so we have, this is a long question again. So let me look at, so what is question 6, right? So let's see. So these are all basically university level questions at this point. But you probably would not be asked any of these guys in probably in a secondary level setting. It's more so in a university level setting for most of these problems here. So biphenyl is, again, I have C12H10, right? So let me write this down, C12, or I'm giving the mass of both of these guys. So let me just write down the mass of C12H10 is equal to 15.4 grams, and the mass of benzene, which is C6H6, equals 29.7 grams. I'm given at 25 degrees, so at 25 degrees Celsius, the vapor pressure, or at 25 degrees Celsius, the vapor pressure, so I can say P here, of pure benzene, so C6H6 here, would equal 100.84 torr. And it's asking us what is the vapor pressure of a solution if we dissolved both of these guys here. Okay, so in order for us to figure this out, what we have to figure out first is our moles, right? We have to figure out our moles here because we care about the mole fraction, and we can relate moles to our partial pressures as well, and that's why we can't really work in grams here. So in order for us to convert from mass to moles, we're obviously going to divide by molar mass. I know that moles equals mass over molar mass, right? Moles equals mass over molar mass, and therefore, because I have mass here, I want to find moles here, so I'm going to simply just divide by our molar mass. I'm going to divide by the molar mass of this and the molar mass of this. So molar mass of C12H10 would be basically 12 carbons times the molar mass of carbon, which is 12, plus I have 10 hydrogens. I'm going to multiply that by 1 gram per mole here. And this is all done here. Same with C6H6. Again, I have 6 carbons here, and I'm going to have 6 hydrogens here. So I'm just simply finding the molar mass, and I'm going to divide both of these guys. So, and then I'm going to get, let me type this into my calculator. At 15.4, I'm going to divide by basically 144, which is 12 times 12, plus 10, right? And this will give me a value of 0.1 moles of this is C12H10. And then for this guy here, I have 29.7 here. I'm going to divide that by 12 times 6 is 72, plus 6 here would give me 0.38, which is vastly different from what they're doing here. So I don't know what's up. It might be a rounding issue. Yeah, it might be a rounding issue here. So let me instead of doing 12 and 10 here, let me just I'm going to do the exact molar masses, so I avoid a rounding error here. So I'm going to do 12 times basically 12.011 here instead of 12, just to avoid some type of decimal error here. So 12.001 grams per mole, and this here was 10, right? So 10 times 1.001, I believe, is hydrogen, or 1.008, sorry, 8 grams per mole. Just to avoid some type of confusion here, again, this is 12.01 grams per mole, and this here is 1.008 grams per mole here. And then let me do that on my calculator here. And I would get, let's see, so 12 times 12.01 plus 10 times 1.008 would give me a value of, the molar mass is 154.2. If we divide that by 15.4, I would get 0.99 here. So something is up. Oh, I understand why now. they messed up here. So they wrote 17.9 instead of 15.4, and they wrote 27.4 instead of 29.7. So I think they messed up their numbers here. So I guess their solution will be incorrect. So let's just actually solve for this solution here. So this here is going to give me 0.09987 moles. And then let's correct this solution. So 12.01 plus 6 times 1.008 would give me a molar mass of benzene is 78.108. I'm going to divide that by 29.7 here. And this will give me 0.33824 moles of benzene. So now these moles of benzene, so I can figure out the total moles here. If I add both of these guys together here, I'm going to get answer plus 0.09987. My total moles here is 0.48, right? So again, basically different from this value here, slightly different because they wrote they inputted the wrong numbers into our calculation. So this here is our MT, right? Our total moles here. And what we care about is benzene, right? We care about specifically benzene because we already have the partial pressures of only benzene. We don't have the partial vapor pressure for we don't have the vapor pressure for biphenyl here. So what we're going to do is we're going to find the mole fraction of specifically benzene, right? So I'm going to simply just divide moles of benzene by the total amount of moles. So 0.38 divided by 0.48 here. So I'm going to get the mole fraction. I'm doing MF of C6H6 is going to be basically equal to 0.38024 moles divided by basically 0.480011 moles. And this here that's the total mass here, total moles here. This would give me a value of 0.79120. I'm going to do 2 decimal places here. 20 here. And this is the mole fraction here. So once we have our mole fraction, again, what we can solve for is our partial pressure, right? Because we know here our pressure here is our at 25 degrees is 100.84 torr. I can simply find the partial pressure now, right? So I can say that partial pressure, or my pressure here, my vapor pressure here, so P V of C6H6 is going to equal the mole fraction, or X here, of C6H6 times our partial pressure of C6H6, right? So this here would equal, I know it's 100.84 torr. This here, our mole fraction here is 0.729729, right? 7290 times our partial pressure of C6H6. I mean, 7290, right? Yeah, 7920, sorry. 7920. And then I can basically divide both sides by that, and I would get my partial pressure of C6H6, or benzene. Why did I write H first? Sorry. Would be 100.84 torr divided by 0.7920. So partial pressures of basically C6H6 would be 127.32 torr here. So as you can see, this guy here, they did. Oh, sorry. This is the wait. This here is the PO here. Oh, so this is a total pressure. Sorry. So this here is the total pressure. So sorry, I messed up my equation. I subbed in the wrong P here. My bad. So I have this is the total pressure here. Total pressure here, and I'm already given the partial pressure. Sorry. So I'm looking for the total pressure here, which is 100.84 torr here, and I can basically set torr here equals pressure here, equals 0.7920 times 100.84 here. So the solution is 79.875, 79.865 torr, or you can basically round it to 79.87 torr here. So I'm going to say here solution is incorrect because they messed up the first kind of part. The correct answer 79.87 torr, and then basically the reason why is that they messed up this part here. So I'm going to copy and paste it. It was supposed to be 15.4 here. 15.4 here, and then it's resolved in 29.7. Solved in 29.7. So I don't know if I can bold this. Nope, I can't bold this. So this here would equal drastically different moles here. So this I can copy my answer here. My answer was 0.09987, and this guy here was 0.38024 moles. Therefore, it changes our answer to So I'm going to say solution here is incorrect.